Hi, in this video, I'm going to get started with section 5.1 in our trig class. So in section 5.1, we're really doing angles and radian measure. But I found from experience that if we spend a little time reviewing some fraction and radical work before we get started on our trig material, it can really help. So there was a homework you've worked on where you had to do things like simplify a fraction, and you want to keep it as a fraction, not change it to a decimal. And so like if you had a fraction like 32 over 48, you want to try to write that in lowest terms, get rid of any common factors from the top and bottom. So, when you're looking at it, you might not notice what the largest factor would be. So you might just start by kind of dividing by what you do notice. So I noticed 2 went into both of those, and that knocks it down to 16 over 24. But then I also noticed 2 would go again, and in fact, I can see that 4 would work on both. So I might go ahead at this point, divide top and bottom by 4, and I wind up with 4 over 6. And when I look at that, I realize, hey, wait a minute, 2 would go into those, and I ultimately get 2/3. Now, of course, if I had looked for the greatest common factor first, I could have simplified it more quickly. But sometimes I don't take the time to find the greatest common factor. I just divide out what I notice at first glance, and I just make sure that I keep on doing that until I can't divide anything else. So this would be, the directions would probably say to simplify, and this would be the answer to that, okay? All right, so of course, if you had noticed that 16 was common to both, you could have just divided by 16 right from the start and come up with the 2/3, but sometimes it's harder to find what's the greatest common factor first. Also, learn to use technology. You could do this on your calculator. You could do 32 divided by 48 and then just use the key that switches back and forth between fractions and decimals. Or you could use the ABC button, kind of looks like this. You could type in 32, ABC 48 and hit enter, and it will bring it back as a fraction. And on my calculator, it kind of looks like that in lowest terms. All right, so you want to be getting pretty good at that. Let's look at the second problem here. So the first problem was just simplifying a fraction. Second problem is also a simplify, but this time you're simplifying a radical. I want you to be able to do this without depending on your calculator and to see the process. So 20, we can break it down into 4 times 5. Some people would stop there. Some people simplify radicals by looking for like in this case, the perfect square that divides into 20, and that would be 4. And since 4 is a perfect square, I know I can do the square root of it and get 2. Others keep going just a little bit more till they get to here because they like to look for pairs of factors. So we can see that a 2 would be outside the radical and a 5 would be underneath. Okay? And so your final answer on number 2 would be 2 square root of 5. All right, on the third one, this one is also one that needs to be simplified. You really can't have radicals left in your denominator. So we are simplifying, but sometimes they'll talk about rationalizing the denominator. So this happens a lot. This particular thing happens a lot in trig. So you have to be able to rationalize denominators. So in a case like this, we could get rid of the radical in the denominator by multiplying by the square root of 2. If we do that in the denominator, we have to do that in the numerator. And so we'd have 3 square root of 2 on top over square root of 4 on the bottom, and the square root of 4 winds up being a 2. And so we have 3 square root of 2 over 2. That would be the fraction when it's fully simplified, simplest radical form. All right. Now, the fourth example I wanted to do from homework is important. We wind up needing to use the Pythagorean Theorem quite a bit. And one of the things you can use it for is to find the missing sides of a triangle. So for instance, this one, we needed to know what x was. I should have said missing sides of a right triangle. So the Pythagorean theorem only works when you have a right triangle. Okay. And what it says is if you have a right triangle, okay, then if you take the two shorter sides and square them and add them up, they would equal the square of the bigger side. It goes both ways. If that relationship holds true, you know it's a right triangle. And if you have a right triangle, you know you can say that. All right, so here we have a right triangle, and I did one where the orientation of the triangle is a little weird. So the important part is to identify or be sure you know that 14 is the long side. It's opposite the right angle. Okay, so you would set this one up by doing x squared plus 4 squared equals 14 squared. Okay, and then the rest of it is going to be trying to solve that for x. So we have x squared plus 16 equals 196. We're going to subtract 16 from both sides. Okay, when we do that, we wind up with x squared equaling 180. All right. At this point, we're going to come in and take the square root of both sides to undo the radical. When you do that, don't forget to take both the positive and negative square root of it, even though in this context, only the positive one makes sense. And then we're going to wind up with x equaling positive or negative, and we've got to simplify that radical. So we're going to take that 180, we're going to start breaking it down as far as we can. And what I see is that we got 2 2s, so it's 2 2s, 2 3s, and a 5. Okay, so if we're trying to do the square root of 180 and we're looking for pairs, we're going to be able to bring out a 2 and a 3, but a 5 doesn't have a pair, so it'll be stuck underneath. So the square root of 180 turns into 6 square root of 5. Okay, and then because we're looking at the lengths of the sides of triangles, we really don't need the negative one, only the positive one makes sense. So this side right here would be 6 square root of 5. Okay, and that can be typed in so you can see what the decimal is for that, but most of the time they're going to want it like that simplest radical form. Okay. All right, so I'm going to do just a little bit more with radicals. So I want to go on and, I said the wrong thing, a little bit more with fractions. Just want to do one more thing with fractions that kind of sets us up for what we're going to handle next. Okay, so I wanted to look at how to make sense of fractions. And I just have some blank number lines that have been cut into various number of parts. And if you start building your number sense with fractions, it helps us when we get to where we're trying to identify angles. So, we have 0 on one end and 1 on the other, and we've cut that line segment into 2 equal parts. So that means that tick mark should be 1/2. See how there's 2 equal parts. The bottom number's 2 because of that, and we're at 1/2. And then that tick mark would really be 2/2, which would equal 1. Okay. All right, and then see how this one is broken into 3 equal parts, broken into thirds. So this would be 1/3, this would be 2/3, this would be 3/3, which would equal 1. Okay. So I want you to get used to counting like that and also simplifying your fractions. Okay. So see how this one has 4 equal parts. So we're in fourths, and this would be 1/4. This would be 2/4, which is the same as a half. This would be 3/4, and over here we would have 4/4, which equals 1. Okay. All right. Now the next one is broken into fifths. We don't really do that very often with angles, but we can still use that process. That would be 1/5, 2/5, 3/5, 4/5, and then at the end we'd be at 5/5, which would equal 1. Okay. We do use sixth a lot. This one is broken into 6 equal pieces. So as you're counting, that's 1/6. This is 2/6, but that reduces to be a third. This is 3/6, but that reduces to be a half. This is 4/6. When you reduce it, you get 2/3. This is 5/6, and then this is 6/6, which turns out to be 1. All right. We don't really use 8s or 10s very often. I'm just going to skip those. And let's take a look. We don't do this very often, but let's go ahead and check it out. So this is broken into 1, 2, 3. Notice I'm counting the spots in between, not the tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal pieces. So as you're counting, it's 12ths. So that's 2 12ths, which is 1/6. 3 12ths, which is 1/4. 4 12ths, which is 1/3. 5 12ths doesn't simplify. 6 12ths is a half. 7 12ths doesn't simplify. 8 12ths, that's going to be what? 2/3. 9 12ths. 3 would go into both of those, right? So that would be 3/4. 10 12ths. 5/6. 11 12ths. And then we'd be at 12 12ths, which simplifies to be 1. Okay, so if you can get used to fractions and how they work, the bottom number tells you how many equal pieces, and the top number it's like you're counting on your way to 1. 1 of those, 2 of those pieces, 3 of those, and so on. We're going to do this, but what we're going to do is we're going to have a circle ultimately, and we're going to need to kind of know where we are on this circle. So if I broke it into pieces like that, that would be 1, 2, 3, 4, 5, 6 pieces. So this would be a sixth of the way. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 of the way around that top half of the circle. So we'll do more with that later. I'm going to create several kind of small, short videos on this. So I'm going to stop sharing it.